In this episode, we are going to go through the Tempest challenge, and this is a part of the SOC Level 1 capstone challenges, which is a part of the SOC Level 1 pathway of TryHackMe. And the capstone challenges are essentially the very last module in the SOC Level 1 pathway that they added relatively recently, I think maybe over the last 6 months or something like that. And these are all just a bunch of challenges. There's very little information. I feel like there might be some information that they're going to give us in forms of like lecture format or something like that, but I think they're splitting the challenges into individual segments. So this is what I believe, this is what I'm assuming is going to happen, because they all fall under challenges in general. So that being said, this is the room that we're going to go through, and it's a part of the module that we're going to go through. And essentially we are doing a big capture the flag type of exercise, and we're going to try to capture as many different flags and answer as many different questions and solve as many different challenges as we possibly can. So we have the intro, we have the preparation for log analysis, preparation tools and artifacts, initial access for the malicious document and the stage 2 execution, and then malicious document traffic. All of that falls under initial access. Then we have the discovery for the internal reconnaissance, privilege escalation for exploiting privileges, and then actions on the objective, which is fully owned machines. Now, this sounds like it's a series of actions we would have to take for a penetration testing exercise, but we are technically in SOC Level 1, and we are Security Operations Center analysts. That's kind of what we're doing here. So I wonder if we're actually going to be running pen testing exercises, or if we're trying to kind of trace the steps of somebody who did all of those things, and we have to catch them. That's kind of what I feel like we would be doing, or that's what I'm assuming that we would be doing. So anyways, that is the Tempest challenge, and we're going to tackle it together today. And if you don't already have access to TryHackMe, I would highly recommend that you get it, because it is a controlled environment. I did find out last week that they discontinued their referral program as of November of 2024. So unfortunately, there's no longer a referral program, and I'm very sad about that. But I still think it is an amazing bang for the buck. So if you do get the annual membership, you get a discount on the membership. If you don't, and if you just want to pay the $13-14 a month, whatever the price is, I still think it's very, very worth it compared to everything else that's available on the market. You get access to a bunch of virtual machines, and you get to do these cybersecurity and hacking exercises in a controlled environment where you don't get caught up. And if you do something, or if you scan a machine or something like that, which is a felony, you won't get into trouble for it. All like none of that will happen, because you're in a controlled environment, you're in a lab environment, and you get to do all of these practical exercises. So I think it's very, very worth it. I get nothing from this. Back when there was a referral program, I would get some kind of a referral credit, but from that, it doesn't even exist anymore. And I still stand by TryHackMe, and I think that is a very, very powerful resource. So again, highly recommend it. And if you don't have it, you can kind of just follow along with the lecture and with everything that we're doing, and then try to do it in your own environment. But again, it's just easier and more convenient, and you get into less trouble if you actually use TryHackMe. So that's my whole spiel on that. If you're serious about your CySec training and want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the supporter, agent, guardian, and master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@hankhackshackers/join, and you'll be able to join Hackaholics Anonymous. Now, without further ado, let us jump into the Tempest practical exercise. Okay, so the intro actually tells us that we're going to be analyzing endpoint and network logs from a compromised asset. Given the artifacts, we'll aim to uncover the incident from the Tempest machine, and will be asked to be one of the incident responders that will focus on handling and analyzing the captured artifacts of a compromised machine. The prerequisites would be the Windows event logs, Sysmon, Wireshark packet operations, and Brim, and all of these actually have videos dedicated to them inside of the SOC Level 1 playlist, and you can go find them It's in the title, but you can also just kind of search for it and you'll be able to find it. There are multiple videos on the channel for event logs. There are multiple videos on Sysmon, multiple videos on Wireshark, and I think there's only one video on Brim, and that would be inside of the SOC Level 1 playlist. The investigation environment is going to be the virtual machine that I've already started, and we can actually see that on the right hand side of the screen, which is this machine. I'm going to open it up into full screen in a little bit, and that's what we have. And if you do have TryHackMe and if you want to do this on your own machine, then you would need to connect via OpenVPN, and then these would be the login credentials. The IP address changes every single time that you load this virtual machine, so this IP address that you see right here is not going to work if you just try to randomly scan it, or if you try to break into that machine. It's not going to work, because by the end of this video I'm going to break this down and you're not going to get access to it, and you won't be able to do anything to it anyway, because you would need to be connected to the TryHackMe servers through OpenVPN. If you don't have that, then it's just not going to happen. So that is it for the overall setup and the introduction of this video. So let's actually look at the very first preparation step over here, which is the log analysis step. So as a review, we need to go over two general concepts. One of them is log analysis. The next one is event correlation. So every event that happens inside of a given network or inside of a given machine generates some kind of a line item inside of a log. So if it's the authentication log, if it's the web server logs for Apache or Nginx, or if it's the system logs, the security logs, whatever it is, there are events that are generated that get logged. Now, log analysis is the process of understanding those events that are generated to identify anomalies like a security threat or an application bug, system performance, or anything else that may impact the organization. And the log file has an audit trail, or it is an audit trail of events or activities that happen inside of any given application or the system or the network at large. And logs automatically audit any activity that's configured, like these system messages, authentication attempts, network traffic, basically anything that happens on a computer, down to a click. If you click on something and if you open something, there is a log item that's generated for that activity and that event. So just keep that in mind. For in a good environment where you have these things set up, there pretty much everything can be logged. I'm not going to say they will be logged, because depending on how the system has been configured, they may not log the smallest things, right? But for the most part, you can log essentially everything. And the concept or the philosophy of the security analyst and the penetration tester is to be the most paranoid person that you can be. And so that means assume that everything is being logged. And especially when you're on the offensive security side and you're pen testing and ethical hacking, just assume that there is everything that's being logged, and everything that you're doing at some point can be reverse engineered and tracked back to what you did. So just keep that in mind. So that's what log analysis is. Now, event correlation is when you use the relationships between the different logs, right? So an event that takes place can generate events or individual line items in different log sources. So it could be the application log and the endpoint log and the network log that generate these items or these individual events that combine together, they correlate together to make up the big incident that has taken place, right? So if we're doing an incident response exercise, we can look at the overall thing that happened, right? So, one of our networks was hacked into and they stole some data, So that's the incident, right? When we look at that as the overall connection of all of the individual events, it's easy to say, okay, so for this big incident, there were 4 log sources that generated a bunch of events, and then we need to correlate all of those events to try to figure out what happened in this incident, okay? So event correlation deals with identifying the significant artifacts that coexist from different log sources and connect them to each related artifact. So a network connection log may exist in various log sources like the Sysmon log or the firewall log, and the firewall log may provide the source and destination IP, source and destination port, protocol, and the action taken. In contrast, Sysmon logs may give the process that invoked the network connection and the user running the process. So all of those individual items or artifacts come together to give us a full picture of what this person did in this given series of actions that he took, or he or she took. So with this information, we can connect the dots of each artifact. So source and destination IP, ports, action taken, protocol, process name, user account, and machine name. All of those things can come together. So event correlation builds the puzzle pieces to complete the exact scenario into an investigation. So there's that. So now we can look at the tools and the artifacts that we would use in a given environment, and just overall what that whole process would be like. The list of activities, or the list of tactics that we're going to use or go through in this specific section is going to be for this investigation that we're running for this video. So we're going to talk about the artifacts and the tools that would be needed for that. The very first thing that we want to look at is the hash value, the checksums of the individual artifacts that we're looking at. And this has to do with chain of custody and making sure that the integrity of the artifact has not been altered, right? Nobody's tampered with the given artifact. So if we go into, for example, the desktop incident files location and then list the incident files, which is going to be these three files. We have a PCAP file, a packet capture file. We have a few, it seems like executable files. Let me see if that's indeed the case. Let's see what the breakdown would be. It doesn't say what the extensions are. We could find out what EVT, or I think if I click on it, it might be able to tell me. No, it doesn't tell me. Okay, so but in either case, whatever these things are, what we need to do is we need to first get the hash value for it. Now, if we're using PowerShell, it's going to be a very different command than if you're using a Linux command line. And this is called a commandlet, essentially anything that has a verb at the beginning of it, and then it has this noun that we want to get. So we want to get the file hash, and then the algorithm that we want is SHA-256, and then we want it for this specific file, which is the PCAP file that we have, the capture PCAP file. So then it gives us the hash value. So algorithm SHA-256, this whole piece right here is the hash value, and it's for that given path or that item. So when you look at that, or when you start collecting this data, you can say, okay, well, these are the hash values that we have now for this version of the file that exists in here. And then we need to compare it to the different hash values that are generated inside of these endpoint logs, or the various logs that we're going to look at, to try to compare and see if the hashes have changed, therefore implying that the file somewhere along the way was either altered or tampered with or edited, modified, etc. So then we have the tool set, which is needed, which is going to be analyzing for the sysmon logs, Windows ML logs, and packet capture. So we have the endpoint logs. And to be able to analyze these things like the Windows event and sysmon logs, we're going to use the EVTX ECMD and then the Timeline Explorer, Sysmon View, and Event Viewer. For network logs, we're going to look at the Wireshark and Brim tools, and then these are listed in our taskbar. And again, so if you don't know how to use Wireshark, there's videos for that. If you don't know how to use Brim, there's videos for that on this channel, so you can go just find those, and there are very detailed breakdowns on how to use those tools. All of these things are covered by the prerequisite room, so we'll only cover the new ones in this section, meaning we're not going to go through the details of these specific tools because we have other videos that exist on them, but all the new tools we're going to go through. So for example, EVTX ECMD and Timeline Explorer. So Zimmerman is a big name in this world of incident response and analysis and security, and he has a set of forensic tools called the Easy Tools by the Eric Zimmerman creator, the Eric Zimmerman author, developer, etc. We're going to focus on the EVTX ECMD and the Timeline Explorer, and they're mainly used for parsing and analyzing EVTX logs. So EVTX ECMD, I need to find like a different ways. I'll just call that double E or something. It's a command line tool which parses Windows event logs into different formats like CSV, JSON, XML, da-da-da. You may use this tool in conjunction with the Timeline Explorer created by the same author. Timeline Explorer is a GUI-based tool. It has a graphic user interface, point and click, drag and drop, basically. And it functions as a data filtering and navigating application to ease incident responders in handling raw data. To parse the provided logs, we need to convert the EVTX logs into CSV using the EVTX ECMD, and then feed it into Timeline Explorer. The command for that would be this. So being inside of the tools EVTX ECMD, we're going to call on the executable, and then we're going to say, this is the file that I want you to convert for me, basically. And then I want you to convert it into a CSV, and then the output is going to be this thing. and then it's going to be the sysmon CSV. So the output is going to be in this folder, and then this is going to be the file name that you're going to output it for me to, and then it's going to do whatever it does, and then it basically processes log. This is a lot of data just to convert something into a CSV file, but it will go ahead and do that. It'll process that file and it will convert it into a CSV file. Then for Timeline Explorer, we can load that CSV file by doing file open, choose the file, and then from this location, very, very simple. If you've ever loaded anything into any kind of a software that allows you to load something, it's a very, very similar process. And then once it's loaded, you can navigate through each item looking at something like this. So this is, if you don't know what a CSV file is, it's comma separated value. And usually when you want to access that data inside of some kind of a graphical format, you would be able to open it inside Google Sheets, for example. You'll be able to open it inside the Timeline Viewer tool, as we're looking at here. So technically, you could even just open the CSV file that we get from this conversion, the sysmon CSV. You could technically open that in Microsoft Excel, technically. You can also technically open it in Google Sheets. And then it will give you a similar view, but it probably won't give you the functionality that's available in Timeline Explorer, which would be very relative to cybersecurity incident response activities. I hope so. I hope there's like extra functions that we can do with it. So you can use the search feature in the upper right hand corner to find a unique string that may exist on any column. You can also do that inside of Excel and my Google Sheets. So Sysmon View is a Windows GUI based tool that visualizes the Sysmon logs. Before this tool, we must export the file's contents into XML via the event viewer. So we would open up the event viewer, and then we will look at whatever the event is that we're trying to do, and we would save it as an XML format. So you can see right here at the bottom, it's saving it as an XML format, and then it'll go ahead and export it for you into an XML. And then from there, you would import the Sysmon event logs inside of the Sysmon View tool. And once loaded, the left sidebar has search functionality that can filter a specific process in mind, choose the image path, and the session GUID or GUID. What a GUID? Who even says that? The session GUID to render the mapped view. So this one seems to be a little bit more functional than the Timeline Explorer. And I can't wait to actually use it and see what we got. So this tool can easily view the correlated events from a specific process. The example above summarizes all Sysmon events related to the explorer.exe, which is what we see right here, the explorer.exe and the path for it. And then it gives us all of the events that have been correlated, which is actually kind of cool. So I like this tool already. So this tool does that. Okay, great. So we talked about that. So what is the SHA-256 hash of the captured pcap.ng file? So this is actually up here. So I'm not going to run the command. We should already be able to access this 256 hash. I hope this is actually the value. Otherwise, I have to run the event and confirm that that is it. And if the value has changed, that means that somebody tampered with the file. So there we go. All right, so that's correct, but we also do need to get the Sysmon EVTX and the Windows EVTX file hash values. So we do get to actually run that command. So I'm going to open up PowerShell on our machine here. And what we need to do is, where's the files located? It's inside of the, what is it, incident files. So that's where we're trying to go. I need to let PowerShell load because apparently it's taking its sweet time here. So this is what we're going to do. We're going to open this in full screen mode, and then we're going to minimize it here. And then what I'm going to do is I'm going to open this link in a secondary window, or my secondary monitor, excuse me, so I can still read through the instructions while I am navigating everything on our terminal here on our full screen. And it still hasn't loaded. That's crazy that it's taking so long for the PowerShell tool to actually load. It's kind of mind-boggling, my friend. Okay, so we're just gonna give, oh, you know what? I think I might need to allow it to do something. Maybe that's what it is. All right, so we're gonna give it a second for it to load, and we'll get right into it as soon as it actually loads. Cool, so it is officially loaded, and we actually have it on our screen. So let's zoom in on this bad boy a little bit so we can see what's going on. So this is what we got. We got the LS of this particular location. So I need to go into the desktop, I believe, and on the desktop or let me actually clear the screen. So let's do ls on the desktop, and we have incident files. So we're going to go into the incident files location, do ls over here, and those are our files. So now what we need to do is run that get file hash command and get the SHA-256 of the two EVTX files that we have over here. So let's do that. Okay, well, I tried to be clever with it, and I tried to do both of them at the same time, but it didn't work. So what I'm going to do is I'm going to try it one more time to do them together, and then I'm going to separate them by commas. And if that doesn't work, then I have to do it individually. So let's run that one more time, actually, and see if we can separate them by commas for it to work. And it does work. Okay, great. So if you separate them by commas, then it works. So here we go. What is it? SHA-256 of the first path. Okay. I need to know what this actually is. That's the part that's interesting. Okay. So I'm going to assume that the first one is the sysmon EVTX, and then the next one would be the Windows, because it doesn't give me the full path. That's kind of interesting. That's actually annoying a little bit. So we will, Control C, and that should be copy. So let's go over there and see if that works. And paste that. Okay, cool. So let's try that. All right, yes, that is exactly the hash value for sysmon. And then we're gonna copy this bad boy, and then Control C, go over here and do the paste, and voila. Cool. So we got all of the hash values that we needed. So now we need to do the initial access for the malicious document. So we need to look at that event. And I'm going to zoom in on this a little bit to make life easier for us to read these things. So we are now officially the incident responder from an alert that was triaged by one of the Security Operations Center analysts, and they've confirmed that the alert has a critical severity, which means it's really important and we need to address it immediately. As reported by the SOC analyst, the intrusion started from a malicious document. In addition, the analyst compiled the essential information generated by the alert as this. So we have malicious document has a doc extension. The user downloaded the malicious document via Chrome, and the malicious document then executed a chain of commands to attain code execution. To aid with this, you may refer to the cheat sheet crafted by the team applicable to the scenario. So start with the events generated by sysmon, then Timeline Explorer, so EVTX ECMD Timeline Explorer, then sysmon view can interpret the sysmon logs, follow the child processes of WinWord, then use filters like parent process ID or process ID to correlate the relationship, and we can focus on sysmon events like the process creation and DNS queries to correlate the activity generated by the malicious document. Significant data sources would be sysmon. So the user of this machine was compromised by a malicious document. What's the file name? What is the name of the compromised user and machine? What is the PID of the Microsoft Word process that opened the malicious document? Based on sysmon logs, what is the IPv4 address resolved by the malicious domain? And what is the base 64 encoded string in the malicious payload executed by the document? What is the CVE number of the exploit used by the attacker to achieve a remote code execution? And that is the last question for this particular segment. So I have all of these things open on my second monitor. So we're going to go in this location here. We're going to clear our PowerShell, and we're going to open up our incident files. There are a couple of things that we do have to do, right? So remember, we need to convert them into CSV files so that we can use them, etc., etc. So the first thing that we need to do to be able to convert them was using the EVTX ECMD to actually convert the file into a CSV file. And that was a command, if you remember, that they shared with us. So I'm already inside of the incident files folder inside of the PowerShell window. So I'm just going to pull up the EVTX ECMD command, which is it's fairly simple, but it's a pretty long command. So let me go ahead and pull that up on my second monitor, and then we'll run it over here. And then we should get a CSV file for each one of our EVTX files. Actually, so we need to be inside of the tools directory that has the EVTX ECMD directory inside of it. So I'm already in here, and then we can see that we have the executable for that. And so now we're going to run it, the command here. So it's going to be dot Okay, so there we go. There's our command, and now it's working. So let's see here. I mean, it should be fine. So let's see, CSV output will be saved to this location, and it's going through the motions. I don't know how long this is going to take. So let's see how long this actually ends up taking. Okay, so it only took 176 seconds because when you get to the first portion right here where it says CSV output will be saved, I guess you still need to press enter. So I did not press enter until like literally 5 seconds ago, 10 seconds ago. And then when I did press enter, the rest of this took a very, very short, it just took a few seconds. So just keep that in mind. You do have to press enter when you get prompted. The CSV output will be saved to, etc. So this is the first one. This is the first file that we converted into CSV. And then what we're going to do is we're going to, because I'm pretty sure we're going to end up needing it for the next few tasks, is I'm going to convert the next file as well. So let's now convert the next file, which is going to be our, what's the name of the file? I already forgot the name of the file. The Windows EBTX. So we just converted sysmon EBTX. Now we're going to convert the Windows EBTX file. And we could just do this. We can press up on our command, and then we can go ahead and change this name into Windows, and then we can go, whoops. So you do need to, let's see. You can't press up again. You have to actually press back on this thing. So we're going to do back, and then we're going to go and deal with this file, and it's going to be Windows, like that. There we go. And so that's going to start, and then so there you go. That one did it automatically. That's so weird. Okay, so I mean the first one I had to press enter, but this one automatically did it, and it took 2.3 seconds. So much faster than 176 seconds. Okay, so cool. Now I actually have my file converted into a CSV file. So since we're only dealing with the sysmon file for this series of questions, what I'm going to do is the first thing that I'm going to do is I'm just going to open it up in the Timeline Explorer, and I'm going to open it up in sysmon view and see what we can actually find about this data. I'm going to try to open them up both at the same time to kind of just try to save some time. Hopefully the computer or the virtual machine that we're in can actually handle it. So let's see how that ends up working. Here we go. These are our files that we have over here. So first we're going to open up the tools. We'll open up a new window, which is going to be the one that will access all of our tools from. So I'll go into, what do we got? This PC. We're going to go into the local disk. We're going to go into the users. Then we're going to go into user. And then we're going to go into the tools. Where's the tools? Oh, you know what? My bad. So it's actually, we got to go to local disk, and it's right here. So you don't go to users. You go to local disk, and then you go to tools. And then here are all of their tools. So we're going to do Timeline Explorer, and we're going to open up the Timeline Explorer, and then I'm going to go back to tools, and then we'll go to sysmon view, and we'll open up sysmon view. So I'm going to open both of them up at the same time. Let's see if this is going to crash the VM that we're on. Okay, that wasn't that bad. So sysmon view opened up literally within like 2 or 3 seconds after that. And then in the background, I have Timeline Viewer or Timeline Explorer that opened up. So now we're going to do this, right? We're going to click File, we're going to open it, and then we're going to go into the this PC, and then we're going to track down our user because all of our incident files are on the desktop of the user. And then we're going to open up the sysmon CSV inside of the Timeline Explorer. And I think we are supposed to also use the CSV version of the file to go to sysmon view. I wonder if that's what they did. So let me review that real quick. No, actually, so in order to be able to make it viewable for sysmon view, we need to open up the log file inside of event viewer, and then from there we can convert it into XML format. So that's the piece that we have to do. I am curious if we can just use the EBTX ECMD to convert it into an XML format. So let me see if that exists, because if that does exist, I think it would be faster to just convert it into XML via the command line. Okay, so it seems like we can actually do that. So I'm just going to open up my PowerShell one more time, and we're going to go back into the EBTX tool that we used recently. So let's do this. I'm going to clear the screen so we can go back to the top of the screen real quick, and then we'll run the command that we had right here. So this is the last command that we had, and we'll actually even go up one more because that's the one that we used for the sysmon file. So the first part is going to be the same, right? So we're just going to use this as our reference file, which is EBTX, and then instead of turning it into CSV, we're just going to turn it into an XML file. So right here, I'm going to do XML as the extension. And then for here, we're going to, I think the main thing that we need to do, let's see, we'll do this just to make sure. I think, let me zoom out a little bit to make it a little bit easier. Instead of it being a CSV file, it would be an XML file like that. And then the location would still be the same, and the output format right here is going to just say XML. So let's try that. Let's see if that actually works. Okay, cool. So that actually worked. So what do we have? We do have the sysmon XML file, and it's been saved accordingly. So the command was very similar to the last one. The only thing that I modified was that instead of CSV over here, it says --XML. So we're still referencing the original file being exactly the same as the last time. Format output is going to be XML. The location is still going to be the path that we want. And this right here is the last piece. So it's kind of hard to see it, but it says --XMLF. So originally it was CSVF, but we're going to do XMLF for an XML file, and then we're going to give it the sysmon.xml name. And then if we go into our file explorer, we should actually be able to see the XMLF availability here, which is this file right here. So it says XML document, boom. So that's cool. So now for PowerShell, or no, excuse me, where was it? It was the timeline explorer. It's already loaded as a CSV for sysmon view. I'm just going to go here, and I'm going to import an event log, and we're going to do it in XML format. So let's see if we got it. That would be cool if it did indeed work and it made it fairly simple, because I think it's faster when you can do things inside of the command line. So desktop incident files, there is the XML file, and we open that, and easy money. Look at that. This operation may take some time depending on the size of the file. Cool, no problem. Import. All right, so we're going to let that, that was it. It's like fast. Logon UI exe. So if I click on that, and then let's say click on that as well, and then click on this, it'll open this up for me. And there's no other information here. If we do the map view, oh, we don't, that's an actual map. If we do an all event view, it's just a one line item. And if I do hierarchy view, nothing. So the main view is the process view that we want. And so this is what we got. So logon UI.exe, Tempest, summary of events, process creation, etc. So what was the question here? So it says, let's see, malicious document. There should be a question that has to do with the file, right? So it says, by a malicious document, what's the name of the document? It can't be the logon UI.exe. I don't think that's it. Based on that, what's the malicious domain? Base64 encoded CSV number. Okay, so none of these things are actually relevant to us. Winlog.exe might be the executable, so I'm going to try that to see if that is the name of it. But again, I don't think, no, it's not. I don't think it is, because it's too short for the answer that they're looking for, so we can just automatically assume that that's not it. Now, let's see if there's any more data. Boom, actually, there's a lot of data. Great. So we do have a lot of data with each one of these things. So we do want, what do we want? We want a PID of the Microsoft Word document that is open. So we are looking for a doc, right? So it has a .doc extension. So let's see if any of that information is useful here, or if I can find it. So I'm just gonna kind of like click around and try to find any information that I possibly can. And then from there, we'll try to come back and see what we can do. Okay, so nothing so far. There are some commands there is a command line element that's actually useful here. We do have a SHA hash value. We have an import hash value, a parent process GUID parent process, but these all have to do with the individual winlog exe, which is not the specific item that we're looking for here. So it says, what is the PID of the Microsoft Word process that opened up the malicious document? So this is definitely not what we're looking for in this case. I think these are going to be useful to us. I just don't think they're going to be useful to us right now. So we're going to go to the timeline viewer here, and I will expand this so we can see things a little bit easier. So we can search for anything. So what I'm going to do is I'm going to do .doc, and I'm going to press enter and see if there's anything that shows up. Okay, so we have several elements or several line items that actually have shown on. So the provider is Microsoft Windows Sysmon, channel, process ID is 2800, computer is Tempest, user ID is this guy. Let's see what else we find if we go down the line here. We have file creation, username, payload data, and what else? Payload data part 2, payload data part 3, payload data 4, 5, 6, executable info. Ooh, we're getting close. We're getting some good information. And then source file, payload itself in entirety, which is a very long thing. Okay, so let's see. So let's look at some of this data here. So we first and foremost, we just want to find that file name. So payload data part 1 doesn't really give us much. Payload data part 2, if we expand it, still doesn't give us much. Payload data part 3, if we expand it, gives us some file names and some executable names. It gives us some paths, and we are looking for that doc extension. So let me see. I'm going to try to track it down, and I'll tell you where it is. Okay, so here are all of the docs. It's under payload data 4, and it's literally the very first one that says users Benimaru downloads free magicules.doc. And we have a couple of other doc files, but I feel like this is the one. So if we actually go ahead and input that, I already input it, and I know for a fact that it is the one because I wanted to make sure that that's the right answer. So that is indeed the right answer that we're looking for. So it is free magicules or magicules, whatever, .doc. That's the first answer. So it says, what is the name of the compromised user and machine? And that's also in that same path that we just had, which is Benimaru. I believe that's their user. So users Benimaru. So let's see if that works. Imaru. It's not. So it's format is username and then the machine name. So it would be Benimaru dash something something. So we need to find his machine name real quick. Oh, Tempest. I think his machine name is actually Tempest. So let's do Benimaru dash Tempest. Yep, that's the machine name. Okay, cool. So Tempest was his machine name. Let's see if we can actually find that information over here so that you know where it is. I mean, I kind of deduced it because at the very beginning of this exercise, they did say that we were working on the compromised machine, which was Tempest. And so this is what we have. So Tempest Benimaru. Tempest is the host name, Benimaru is the username. And so that is how you get the format that they gave us, because they just said username and then dash machine name. And that's the one that we got. So Benimaru Tempest. Now it says, what is the PID of the Microsoft Word process that opened the malicious document? So this is the next thing that we want to look for. So we have event record ID, event ID, provider, process IDs right here. So 2800 is these processes that we have over here, but I don't think it's any of those because that actually is not relevant to what we're looking for here. So what we're going to do is we're now going to kind of expand our search, or narrow down our search, I should say. So we're going to do free _ magicules.doc as our search, and let's see what we can find. So now we have a narrowed down data, and so payload number 4 is the one that gives us everything over here. Parent process is what we have, payload data right here. So let's see what we can find in this location. These are all the hash values. Parent process ID 6596, parent process ID itself. So let's see what we can find with this information. Again, I'm just gonna roam around a little bit and see what I can find for you. Under payload data 3, we actually see all of the executables or the images of the programs that ran them. And there's one down here that is a Microsoft Office program, which is the WinWord executable. And so if you go, where is the location? There's a specific payload there right here. So payload data number 1, that actually gives us the process ID and then the process GUID, etc. So the process ID for the WinWord executable is 496. So let's try that to see if that actually works. And that is indeed the process ID. Great. So now based on the sysmon logs, what is the IPv4 address that's been resolved by the malicious domain used in the previous question? So now what we need to see is where this thing was downloaded from. So that's the thing that is interesting to us. So he used Chrome executable to actually download it, but we need to see where this thing was downloaded from. So we are looking for some DNS data here and potential command line items or maybe activities that have to do with DNS data. Okay, so at first I started with the search term download, but then it actually leads us to this series of events over here under map description. And so we have network connection and DNS event or DNS query. So the thing that I'm curious about is the network connection part, because the network connection is what led to me seeing an IP address. So if we just narrow it down by network connection, and then we go down to the payload section, so it's payload data 4. This payload data section gives us a series of IP addresses, and they're exactly the same IP address. So it says source IP, so I do wonder if it's actually talking about the IP address of Ben Imaru. But I do want to try out this IP address to see if that is the IP address that potentially made that connection. And let's see, so 192.168.254.107, and that is not the IP address. Okay, so that's not the one that we're looking for. Based on the sysmon logs, what is the IPv4 address resolved by the malicious domain used in the previous question? So the next thing that we would be doing then is we would be searching for DNS query. So let's do DNS real quick. And then so we have what, fish team XYZ, we have YouTube accounts, Google suggest queries. I feel like it's fish team. I feel like that's literally the domain that we need to talk about. There's also resolve cyber XYZ. I'm gonna take a guess here, and I'm gonna say that it's the fish team domain. That would be something that we would be interested in. So let's see if we can find anything relevant to that domain. So if we do a search for fishteam.xyz, we actually get a connection to the query as well as the file, the free magicules.zone identifier, target file name, and a few other connections here that we had, PowerShell executions, query name, etc. So now we're looking for an IP address in all of this payload data. So if you know what an IP address looks like, you should be able to spot it pretty quickly. I wish I knew if there were ways to we can fine tune our search queries, to see if we can actually potentially combine, fish team XYZ with an IP address kind of a formatting. That would be very, very useful if that was indeed possible. But in this particular case, I feel like we cannot do that. So we're going to go and search through our various payload data and see if we can find any kind of IP address. So it would be, so payload data 5 shows us the process IDs and data like that. Payload data 6 actually gives us what looks like IPv6 addresses as well as what looks like an IPv4 address. So we have 167.119.911. So I'm going to try that one. I'm going to try the 167.71 address, and let's see if that is indeed the case. Yep, that is the address. So we got there, right? We had to first I looked for network connections, and then I looked for the DNS queries. And then based on DNS queries, we saw this domain name that is very fishy, no pun intended. And then when we search for that domain name, we're able to see the various queries that were made for that domain. And then looking under the payload data, we were able to see that there was an IP address that was connected to it. So excellent. We now have that answered. Now, It says, what is the base 64 encoded string in the malicious payload executed by the document? So now we need to actually see the command that was ran and then the base 64 encoding of the payload for that. So now we're going to go back to the, what was it? I think it was like free magicules. That was the name, right? Yeah, freemagicules.doc. And then from there, we need to find the payload that's connected to that actually has a base 64 encoding. So we're going to search for this again. And so we do have a payload or a series of payloads that are over here. And there is a variety of data that we can look for to be able to find that information. So payload data available, payload data 2, nothing in here. Payload data 3 doesn't have anything. It does have the hash values over here that are interesting, but it's not encoded data. We're looking for base 64 encoded data. Payload data 5 section also has a bunch of hash values, and there's a target object location, and inside of this, let's see, there's nothing that seems like the hash value. So if we go through the command line, we free magicule source file, and then we have the full payload data over here that potentially may have the base 64 encoding in there. So I do have to rummage through this a little bit and see if I can find anything of note. Okay, so here's where we ended up with this specific item. So I went through a few different search phrases, and the answer was actually like the most obvious. So let me make sure I renew my machine here. So it's pretty much inside of the answer. So or inside of the question, excuse me. It says, what is the base 64 encoded string? So I searched for a bunch of different things, but the one thing that I should have searched for at the very, very beginning, which is again like the most obvious piece of this, is base 64. Excuse me. So when you search for base 64, there's literally one item that shows up, and that one item that shows up, if you go under executable info, there is this whole tab right here that, I mean, there's a lot of data. So one of the things that you can do, instead of dragging it all the way out, you could just double click on this and it'll open the entire thing for you. And inside of this whole element that you see right here is all a part of that executable or that command that was executed. Now, if you never have seen anything that's base 64 encoding, usually I look for these double equal signs, and then it's always inside of some kind of a quotation. So you see that there's a single quote right here. So if we follow this and then we basically go to the beginning of that single quote, this is what we end up with. So this full thing is a base 64 encoded element. So if I copy this, I am fairly certain that that is the base 64 element that they are looking for. So let's submit that. And that is indeed the answer. So literally the answer was like so simple to search for. And I went through a bunch of different search phrases, and it just happened to be that base 64 was the one thing that I should have searched for that will end up giving you a single item. And then when you go under executable, you can just look at all of this data right here, and then we can see that this is the piece right here. So the last question that they have for this section is, what is the CVE number of the exploit that is used by the attacker to achieve a remote code execution? So this is the piece that might be interesting to us. So the hint says, external search needed. Observe the parent-child relationship of WinWord and the process that executed the malicious base 64 payload. So what is the process that executed the malicious base 64 payload, and then the connection of that to WinWord, and then we'll have to do some external searching here to see what that may be. Okay, so the process that executed the payload. So first of all, this itself is the payload. So if we actually copy this, right, and if we go to a tool like CyberChef, which I have open right here, and I already pasted it in there, it'll decode it for us. So if we have from base 64 encoding, and then we just drop that encoded portion in there, it'll decode it for us, and this is what we'll get. So this is basically a series of commands that run inside of PowerShell, and you know they go into the Microsoft Windows Start menu program startup. directory, and inside of that they download this file from the fish team XYZ website, which is the update zip folder. They output it into the update.zip, and then they expand the archive, meaning extract whatever is inside of it. They go into it, and ultimately they will remove it to kind of try to erase their tracks so that we don't see that anything was downloaded in there. So that's the portion in here that's highlighted right here. That's the everything that we just saw is this portion, which is base 64. So technically that's what's executed. Now we need to find the thing that executes that element, and that is done here. So this is the MSDT executable, and this is actually a legitimate executable inside of Microsoft. And so I did a little bit of research on that just to see what it is. And MSDT allows arbitrary code execution via the MS-MSDT protocol handler, which is this piece that you see right here. So these two elements are the elements that actually allow for remote code execution, but they are legitimate elements of Windows. So MSDT is the Microsoft Support Diagnostic Tool. That's what MSDT stands for. And the protocol handler is what allows the commands to be passed to MSDT, so meaning the MS-MSDT portion, this piece right here. This is what allows the commands to be passed to the support diagnostic tool via a URL. And then this specifically, this piece right here is referring to the troubleshooting wizard. And this series of commands that we can see, these are the ones that help to execute the rest of the commands that you see here, right? So inside of this parameter portion, from here to, where does it go? I think it goes all the way to this element right here. So from the highlighted portion that you see right here, this is the element into which the payload is actually injected, and then we have the text encoded. So all of this stuff that you see right here, these pieces are the portions of it that help with the formatting of what is about to be pasted into it. So it'll take the text encoding, UTF-8, which is another formatting. UTF-8 is encoding or formatting. I'm trying to figure out what the proper word for that is, but it has to do with formatting and encoding. And then it's converting, and then it's converting it from base 64, and then he pastes the base 64 portion into here. So all of this essentially allows for the system to process the base 64, and it's going to convert it from base 64 into normal PowerShell command, so that this helps to bypass the intrusion detection, essentially, because if he actually did inject the PowerShell command in plain text, so to speak, into this, the system would have an easier time to detect that, hey, listen, somebody's running PowerShell in here and they're downloading this file and then they're doing all this stuff. So, and then this last portion right here is whoever the hacker is, he's trying to just basically kind of cover his tracks by making it seem like he's just running a normal Windows process. So it's called obfuscation, right? So he wants to obfuscate his true intentions, and it's designed to make it look like he's trying to interact with a legitimate Microsoft file. So this whole piece, and it actually goes all the way up here too. So like this whole piece right here, the / /.. This whole thing makes it seem like he's actually trying to interact with a legitimate Microsoft executable or a Microsoft file. This is where the actual exploit is, and then this is the element that is helping him to launch the exploit, to actually run the exploit. And so the question is asking us, what is the, let's go back down here. The question is asking us, what is the CVE number of the exploit that's used by the attacker to achieve a remote code execution? So basically what we need to do is just do a little bit of homework on any exploits that run MSDT exe and the MS-MSDT. So what we can do for this is we can just go into the CVE database. So we're going to go into the CVE database because we also need to get the CVE number anyway. So we're going to go into the CVE database, and then we're just going to do some searching. So let me close this thing so we can actually go into the search CVE list. And then from this search, we can start doing some different searches to see if we can actually find anything that might be of note to us. And obviously, there's a lot of stuff that's available for MSDT specifically. So let me see if I can do like a combination of searches. It might also be easier to start with Google, because I think Google like allows it to be a little bit easier to kind of do searches like that. So let's see. We still have a really long list of stuff that comes up. So let's see. I think I'm gonna go to Google, I think, for this, and let's see what I can find by using Google as my search mechanism instead of doing the actual CVE database. Okay, so this is what I Googled, right? So I did msdt.exe and then ms-msdt and an exploit vulnerability, and the first series of results that we get have to do with the CVE 2022 30190 and defense in depth variant, and again FortiGuard Microsoft supports. Okay, so I'm gonna try this. I'm gonna try the 2022 30190 as the and here is actually what it's called. It's called Folina. I've heard that name somewhere. So Folina would be the name of the vulnerability itself, but we're interested in the CVE. So we're going to do 2022 30190, and that is the answer. So look at that. We actually got the answer from this. So there it is. So just to kind of walk you through the thought process here, because I don't want to just throw the answers at you. This is one of the big things that I think people appreciate about the content on this channel, is that we work through the logic of how we got to a given answer. So the big thing that we needed to find, number one, was what was the base 64 encoding, right? So this is the last question that we had. What was the base 64 encoded string? And so to be able to find that, we just searched for base 64, and there's only one item that shows up. And then when you go through the payload data of this one line item, you get to the executable info portion, you double click on that cell, and it opens up this cell for you. And then you have all of this data that you get to interact with and work with. And then it becomes a matter of, okay, can you decipher what's happening inside of this data? The one big element that they were looking for was the base 64 encoded version, so, or the encoded string. So we did that. We found the base 64 encoded string, and that just requires that you can recognize base 64 encoding. Now, if you can't recognize base 64 encoding, what you do is this. You go and you copy this whole thing, and then there's a variety of different tools that can kind of help you extract the data. So if I actually just paste that whole thing in here, you can see right here that the output looks like jargon, because this whole input right here is not base 64 encoded. I know that there is something inside of the CyberChef operations called extract, and then there's a variety of different things that you can extract from this block of text. Now, unfortunately, there's nothing over here that allows us to extract the base 64 encoded element of it, so we would need to find something else. And lucky enough for us, there are so many different tools that are available that can help us actually extract data. For example, Gemini AI or Meta AI or GPT. I only use GPT for like really, really powerful type of commands or prompts if I needed to do some really, really heavy lifting type of stuff. I don't really use it for just basic extraction of stuff, because I don't want to run through credits and kind of get the run through all of the credits that are available to me for the more powerful engines. So I'll use that for like really, really heavy lifting type of stuff. But for something like this, we can go to Gemini AI, for example. So we do go to gemini.google.com. And so we come in here and we basically just, I'm going to paste the whole thing in here. and then do a question like, can you see if there is any base 64 encoded data in here? And then that's it. And then you do that, and it says, yes, there's base 64 encoded data, and this is the base 64 encoded portion. And it literally tells you exactly what portion of it is base 64, so you can see this full piece right here. That's it, right? So it's not hard to be able to, especially if you don't like recognize something. And you can always use a tool like this to help you extract it. And then ultimately what will happen is that you will learn how to recognize these things. And it is a really long block of text. So it's like this whole piece right here, this whole long thing right here is the base 64 encoded portion. Now I would probably actually do this instead of like zooming out all the way like that. I would go to here and I would just go from right below it and I would just highlight the full thing, because you can either just start at the beginning and drag down and it'll highlight the full thing. And then you could even do this, like if you want to guarantee, you can go all the way to like decoded results and to highlight that whole element. And then you can copy that and then you go to base 60 or to CyberChef and then you paste it in here. And then all you need to do is you need to delete this extra piece that we also highlighted. And all of a sudden we see that we have the decoded version. So all of that to say, that's how you find the base 64 portion. And then you can see that there's other stuff that's going on in here, and you can literally also copy this whole thing and go to a tool like Gemini again and be like, hey, so tell me what's going on and what is this command actually doing? And then it can show. So let's see, with just even based on what we asked it says this is designed to download and execute arbitrary code on a victim's machine. The use of the startup folder indicates that the attacker wants to code the run persistently. The URL fish stream is a strong indicator of malicious intent. MSDT is being used to bypass security measures. This is a known exploit. See, there you go. It's already giving you a hint, right? And then from there, you can kind of expand on that. And the long string of these characters is trying to navigate to the system32 folder. So that's just very, very basic use of a tool that's available to you that you can use to decipher something if you're not familiar with it. And that's how we got the answer that we got. That's how we kind of narrowed down and worked through the logic to try to find our answer. Now we can move on to the initial access for stage 2. Based on the initial findings that we just finished, we discovered that there's a stage 2 execution. So the document has successfully executed an encoded base 64 command. Decoding the string reveals the exact command chain executed by the malicious document, and we already decoded it using CyberChef, so we're a little bit ahead of the game here. With the following discoveries, we may refer again to the cheat sheet to continue with the investigation. The auto start execution reflects the explorer.exe as its apparent process ID. Child processes of Explorer within the event timeframe could be significant, and the process creation, event ID 1, and file creation, event ID 11, succeeding the document execution are worth checking. The data sources are still the sysmon. And now we have our questions here. So we have a shorter list of questions. The malicious execution of the payload wrote a file on the system. What is the full target of the path of the payload? The implanted payload executes once the user logs into the machine. What is the executed command upon a successful login of the compromised user? Based on sysmon logs, what is the SHA-256 hash of the malicious binary downloaded for stage 2? And the stage 2 payload downloaded establishes a connection to a C2 server. What is the domain and port that is used by the attacker? So let's start from the top here. It says malicious execution wrote a file on the system. What is the full target, full path of that file? So we actually already have that, and the full path of the file would most likely, I wonder if they're asking for the website path. It seems like it's not. So let's see. Okay, so let's see what's the hint. The hint says the app data environment variable can be simplified. The app data environment variable can be simplified. Okay, so we're talking about a writing of a file of the system, and that is file creation. So when a file is created, it invokes event ID number 11. So let's see if I can do something like this. So let's do event, and if we do event, we can see what the event queries are, and I'm interested in the event ID. So let's see what the syntax of the actual thing is. If we look for something that has event ID, something associated with it, I'm very curious to see what that looks like. So first, let's see if we can find the syntax of what it looks like when there's an event ID in place. Okay, so I wasn't able to find anything by the specific event ID because it doesn't there's nothing called event ID specifically, and then I tried different variations of it. I tried event ID 11, etc. But there is something called file create, which is the map of the process that we're interested in, because we are trying to track down file creation, and we can go ahead through the various IDs, or not the IDs, excuse me, the various parameters, the attributes that we can find here, to see what other data that we can pull from these things. So file creation or file create would most likely be the thing that we are interested in. And so I'll do this. I'm going to hone in on this. I will do file create only. So we actually get all of the file create events. And now we have all of the file create events that we see right here. And there is a way that you can do multiple filtering. I just learned this by kind of doing a little bit of research on this freaking Timeline Explorer tool. So if we go to file, tools, if we go to tools, we can technically, I think we can create like a bunch of different types of filters. And we can do it, if we just do find, I think it ends up being an extra layer of filtering that we can basically put in here. So if we go through this, and then now let's see, because we know that it's going to be inside of the startup directory. If he wants to do some kind of, there we go, sysmon startup term shows up 2 times. Okay, so show it to me. Can you expand this for me or what? Okay, there you go. So you just double click on the 2 and hopefully it'll open it up for you. So now we have 2 filters, or I guess no, it changed the find element up here to startup. So that part is not what I thought it was. I thought it was going to do both of the filters at the same time. And so it removed file create that was originally up here, and it replaced it with startup. But I mean, it's still okay, because technically now we just have 2 results that we need to filter through. And the question now is, what is the question? It says it wrote a file to the system. What is the full target path of the payload? So essentially, where did it write the file to the system? And so that's what we want. Target file name is most likely the answer. And this seems to be the full path. So let's see if this is actually it. Okay, and submit, and that is indeed the answer. Okay, so the target path, and again, the logic for this was it's creating a file, and that's kind of where it started. They're going to go inside of the startup folder to maintain persistence. So where was that element? I saw it somewhere. But it was something that said that they're going to be inside of the startup folder to be able to maintain persistence, or to stay inside of the system. And that is the thing that led me to believe that this is what potentially could be the case. Now, I started with file creation, or I started with event ID 11. That didn't do anything. Then I went into file create, and then that helped me find that. And then from there, I looked for startup, and then that gave me the 2 events that we were able to find the actual target file location for it. Oh, it was actually inside of the Gemini key observation. So that's where I got the startup from. So the use of the startup folder indicates that the attacker wants the code to run persistently. So that's where that thing kind of was planted into my head. So we went into startup. So that's how we found that specific path. Now it says the implanted payload executes once the user logs into the machine. What is the executed command upon a successful login of the compromised user? Okay, finally learned how to create multiple filters. Okay, so there's a section at the bottom right here, and I didn't manually enter this, but we can also see what it looks like when you combine them using this filter portion down here. But basically what I did was this, right? So when you go to any column, there's this little icon right here that looks like a funnel. And if you click on that icon, it opens up this new little pop-up. And then from here, you can essentially search for whatever value that is inside of this column that you can add as your filter. So we are interested in the Explorer, right? So it says a child process of Explorer within the event time frame. We're also going to look for the process creation IDs or the file creation IDs. So process creation in this case, since we're going to be executing something, that means there is a process that's going to be starting. So with that, we are going to look for process creation as one of the filters, and then we're going to look at Explorer as one of the other filters. And then we already know who the user was because we looked at it at the very, very beginning, and the user's host and where is it right here? So we had the username and the machine name. Benimaru was the user. So we know these three elements. So we're going to go to the payload data where it has all of the parent processes, and then we're going to filter for Explorer. And then we would come to the element, which was, what is the other, let me see, what was the other one that we did? Username. So we go to username, and then we're going to select for username, and then we're going to select Benimaru for that username filter. And then for the map description is where all of the different processes were, and we click on that. And then we have a bunch of different processes that we can choose from. In this particular case, I chose process creation as the very first thing, and then I narrowed down as I went forward. So I started with process creation, then I added Benimaru, and then finally I went to the payload for portion that actually had our parent process, and I chose Explorer. Now, having all of these filters at the bottom right here, having all of these filters added, we can then look through a very small set of events that we can hopefully be able to find some information here. So now it says, the implanted payload, what is the executed command upon a successful login? So of course we're going to go to executable portion right here. And so upon a successful login, what is the command that is executed? So let's see what we can find with all of these the executions that we have over here. And I mean, really, honestly, when you look at it upon first glance, really the only thing that even seems fishy is the PowerShell one over here. And OneDrive is fine, VM tools is fine, security health, systray, OneDrive again, VM tools, health tray. So all at Chrome, those all seem fine. It's this thing right here that just seems fishy as hell. So we have the Windows system, Windows PowerShell, it's executing, it's hidden. So yeah, that's definitely very, very fishy because the window itself is in hidden mode, meaning you don't see a pop-up. You don't actually see anything running. And so if that is indeed the case, and of course it's executing the thing from Fish Team XYZ website. So this would be the command. I want to say, I think it's the full thing that we have over here. Let's see what the format is. So let's say we're going to use all of this. I want to say, let's see if it is this full thing. If it's not, we'll try to break it down, but I'm pretty sure that's the full command that they're looking for here. Okay, so this is the only modification you have to make. You need to just remove the quotes that are at the beginning and end of this first portion, and then everything else stays the same. So basically I just copied this whole thing, this whole piece right here, and I went to CyberChef and I edited it inside of CyberChef, and I just removed the starting quote and the end quote for this first portion, and then the rest of it I left exactly the same, and that was the answer that we had over here. So that's all good. So now it says, based on the sysmall logs, what is the SHA-256 hash of the malicious binary that was downloaded for the stage 2 execution? So the malicious binary is this guy right here, the first.exe. I want to say that's the actual malicious binary that was downloaded, it seems. So what we're trying to do is we're trying to find the hash value of this thing. Now, I do know that there's actually a portion of this that gives us the hash value stuff. So this is all hash values here. And so I'm just going to real quick just kind of hoping for the best here. I'm gonna take this SHA-256 hash, and maybe that's the answer, or maybe we have to do a little bit more research, but okay, that's not the answer. It was too good. It was too easy to do. So we are going to, we need to hunt down, I think it's that first exe. That would be the thing. So let's go and see if we can find the hash for it. Okay, so I searched for first exe at the very top right there, and then I'm gonna go to my map description here and do my little filter right there. And then we're going to do process creation as our filter. And so these are the items that show up. And so we are interested in the hash value. And I think it would be the stuff that's available over here. Now, interestingly enough, we are interested in I want to say we're interested in the child process, right? I don't think we're interested in the parent process. The parent process would not be the first exe anyway. It would be the actual child process. So that's the one that we're trying to find the executable information for. So let's see. We have this is really the only one that actually has the executable right here running just by itself as an execution. This is the PowerShell command. This is a cert utility command. This is the only one that actually has the executable running by itself. Excuse me. It's the only one that has the executable running by itself. The rest of them don't even have it inside of the executable portion. So I'm gonna say it's this one. So I'm gonna highlight this whole row right there. And if we come over here, we have the hash values in there. Open this up, and we're gonna grab this. And fingers crossed. Let's see if this is actually value. Cool. All right, that was the value. And so basically all I did, first.exe, and then I went to the map description column, and I just changed map description into process creation. And then from there, we looked at the only one that actually has under the executable, the first exe just running by itself, because these are technically the parent process here is PowerShell. And then this one, the cert utility would be the, all right, I'm kind of confused. I don't know if this is the, like cert util in this case would be the parent process or the child process. But just to be like extra sure, you just say, okay, well, this is the only one that is actually running the executable just by itself. So we have stage 2 payload downloaded, establish a connection to a C2 server. What is the domain and port that is used by the attacker? Okay, so going back to these guys right here. So they just downloaded, right? They downloaded and established a C2 connection. What is the domain that's been used? So if we look at our executables here again, users Benimaru download chexe, download first exe, and let's see if we go to the parent process portion right here. So let's go to parent process portion, and we'll filter the parent process. So I'll go and click the filter button, and I want the first exe to be inside of my parent, and close that out. Okay, so there we go. Now first exe is our parent, and this is the executable that was launched. And when this is launched, it downloads something, right? So when that's launched and it downloads something, then our executables now have changed a little bit. So we have who am I? He's doing reconnaissance, right? Net users, he's doing like reconnaissance. Local group administrators, user Benimaru, all these is recon, right? So he wants to know who he is as the user. He wants to know who the list of the users are, who's inside of the administrators group, and the user Benimaru seems like he's actually switching himself to the user Benimaru. And then finally he launches this thing. So the user Benimaru now downloads this ch.exe, and it's downloading it on this specific IP address, or I think the client itself would be the IP address of Benimaru's machine. So now we want to see what we can do. So if we go look at, let's see, so I'm going to actually clear this filter, or clear these filters real quick. right here, and we still do have, we have first exe still going up over here. So now what we want is to see if there's anything that we can look at for potential DNS queries, because they are making a web request. Interesting. So look at this. We already have a domain name over here. So under queries, this is under payload data 4. We have query name resolver or resolvecyber.xyz, and it's being done by this image right here. So it's being executed by the first exe, and it's resolvecyber.xyz. So that could be the domain name, and we need the port number. So I mean, it's a guess, so I'm gonna guess, but we can also verify this. But if we do resolvecyber.xyz or xyz, and then the port number would be 80, because it's the HTTP port. It's like the port that would be running for any kind of internet connection. You know, if you haven't gone through the networking videos, there's Network Plus that was recently launched on this channel. So there's a Network Plus playlist, and all of this stuff is covered. And this is why it's so important to have a strong understanding of networking concepts. But port 80 is the port that is for establishing just HTTP connections and making requests to web servers and websites and the internet at large. And then when you do port 443, it would be the encrypted version of port 80. So it's just HTTPS. So that is the answer. But so there is a way that you can actually do this to kind of confirm this. So if we know that the domain is resolvecyber.xyz, I can go ahead and basically go inside of my incident files folder, and I can go to the pcapture file, the pcap file over here, and it opens up with Wireshark. Now Wireshark, what's nice about Wireshark is that it'll actually create, or not create, but it'll outline everything that's done inside of a packet in detail. And then you can filter through all of the results of the packets that have captured, you know, using a domain name, for example. So from this right here, so we have 21,000 packets that were captured for this specific exercise. And so we can just go up here and we can add a display filter. And the display filter could be an IP address, or it could be a domain name. So resolvecyber.xyz. And I'm just going to press enter, see if that works. It's not going to work because I think it needs to actually be like one of the given attributes that you would search for in here. So there's another way that we can do it, is we can do Control F for find, basically. And then instead of looking for a display filter, I want to look for a string. And then inside of that, I'm going to do resolvecyber.xyz. And then I'm going to press find. And it says no packet contained that has that string in its info column. So it's not in its info column. So we are going to look through the various different types of search that we can find, because I know that it has to exist, because if it's inside of the sysmon file, it needs to be inside of this packet capture file. So we need to be able to just find what that connection is and where it exists. So let's see what we can find. So let's see. Okay, cool. So the query itself is actually going to be the http.host contains resolve cyber. Now, the reason for this is that usually if it was just a DNS request or a DNS query, we would be able to narrow down our protocols by DNS, but all of the traffic inside of this packet capture file was either encrypted using HTTPS or TLS, and so we'll see it right here as well. So if we scroll down here, we can see that we only have either HTTP traffic, or that as it progresses downward, and it's a very large file, so I would have to like manually scroll. But it goes to HTTP, and then from HTTP it will go to TCP, Transmission Control Protocol, or it will go into TLS. So let's scroll all the way down here, and we have TLS. And so TLS is encrypted. HTTP is not encrypted. and what is it? TCP also can actually have encryption or encrypted type of data. So that all of those things yield the fact that most likely if you just search for inside of the string value or inside of the information portion right here, if you search for the domain name, you don't get any results, which is exactly what just happened to us. So if we search through the filters based on what I recently did right here, which is the host, the HTTP host containing resolve cyber, and then going through that, it actually does narrow down the results for us, and then it'll point immediately to the packet that would contain that value, and then we can see that we actually have it in the encoded portion right here, where we actually see resolve cyber.xyz, connection keep alive, etc. And then so we would go to the TCP portion of this packet. So all of these packets, this is why Wireshark is so powerful. You get to look at the finer details of every packet that took place. So for example, the MAC addresses that were communicating with each other, the IP addresses that were communicating with each other, and of course the TCP protocol that was used, the source port 51962, which is the port of our source IP, which is Benny Maru's computer, and then the destination IP, which is that malicious IP that we established earlier. Or I don't think it was, I recognize the 16771, but maybe it wasn't 222.162, or maybe it was. But the destination port is for sure port 80, especially if it's going to be on the protocol of HTTP. Let's actually confirm what the destination port or the destination IP was, because we did. So it's 167.171.199.191. So that could potentially be the thing. So I could even narrow it down, but that was the initial connection, and the C2 server would be a different IP address. So it actually makes sense for it to be a different IP address, because the initial connection was when the IP address that we connected to actually download that file. And then when we're in stage 2, we need to establish the C2 connection to a C2 server, and so that C2 server was the Resolve Cyber XYZ port 80, and there is that. So now we can move on to initial access the malicious document traffic. So I finished this whole thing, and I had the entire recording, and something happened with my external drive that this is being recorded to, and I lost the recording file for the last portion of this thing that we just went through. So I'm going to go through all of this stuff again. Unfortunately, all of the answers have been filled in. So it is what it is. I'm just going to explain everything as we go through it, just so you can see how we got the answer. That's kind of so it's going to be a little bit quick of a breeze, of kind of like a walkthrough. And the nice part is that you're not going to see any of the mistakes that were made, because we're just going to kind of jump right into all of the answers for it. And so we are starting back up from the malicious document traffic portion, malicious document traffic. I believe that was the last thing. Yeah. So that's the last thing that I'm going to, or this is where we're going to pick up, because this is where the last one left off. So by this point, we have discovered a domain and IP that was invoked by the malicious document. There's another domain and IP that was used by stage 2, logged from the same data. And now we're going to be using Brim and Wireshark to be able to filter the rest of the data. And we're looking for network events that are related to the harvested domains and IP addresses. And this is a simple Brim filter that they provided to us so that we can go ahead and pull this data. Now, the first question is, what is the URL of the malicious payload that's embedded in this document? So I'm going to open Brim back up real quick, and we're looking at the first malicious domain, right? So this was the domain that was used to download the document. So in this field right here, in this filter, we're going to modify it to this piece right here. So I'm going to cut all these things, because this is for later on. And we're going to do the fish team XYZ domain. And then from there, we're going to be able to pull the interactions that were done with that domain. And this is the information that we're most interested in, is the host and the URI. And if anything's being retrieved from a website, we're going to be using the get request method. So if you're retrieving pages from the website, if you're retrieving actual downloads from the website, so all these executables here, the zip file, these are get requests that are downloading the file, and then there's the get request that's trying to access this domain name or index.html to be able to access the rest of the downloads. Excuse me. So there's also the free MagicQules document that was also downloaded as well. So the first question here is saying, what is the URL of the payload embedded in the document? And the URL specifically is the HTML. So this is the page from which all of these other things would have been accessed. And so you can see that it's inside of the 02DCF07 path. And then inside of that, we have all of these various paths as well, or all of these different payloads or downloads that we can access from that specific directory. So it would be http://fishteam.xyz/02DCF07 and then /index.html. That's the specific answer that they're looking for, because the links to everything else, all of these other ones are download links. These would be the links that if you visited that combined address, it would download this executable, it would download this one, etc. So that's the first question, is what is the URL of the malicious payload or the malicious payload embedded in the document? Now what we're looking for is what is the encoding that's used by the attacker. So if we went to look at the requests that were being made, we would be able to see certain encodings that would be done, right? So the encoding used by the attacker on the C2 connection. The C2 connection was then done on the other domain name that we had, which was, the Resolve Cyber. So that's the domain name that actually had that connection, the C2 command and control connection. So we need to change our HTTP right here to Resolve Cyber, and then we'll be able to see all of the requests that were made to that specific domain. And we pull it up right here, and then you can see a bunch of this stuff. So there's a bunch of get methods, and then these are the requests that are made. So if I highlight this and I copy that, and if I go to CyberChef and I just paste that over here, this first portion is just the path, right? And then this question mark Q equals is the parameter that's been passed on to that URI. So that would be the query essentially that's being sent. So if we just leave it at this is what we see right here. This is the actual query that he's sending to our machine, and it's base 64 encoded, right? So we already established that also earlier on in this exercise, where we saw that he was submitting base 64 encoded requests when we were looking at the timeline explorer. So that is the encoding that's used by the attacker, which is base 64. Now, the malicious C2 binary sends a payload using a parameter that contains the executed command, and we already talked about that right now as well. So that's the parameter right there. Anything that you see after this question mark, that's essentially a parameter. And then the equal sign means that for this parameter, right, for this Q equals, I want to have this base 64 encoded value. So the parameter will have a value. So Q equals da 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 da. And the parameter in this case is going to be Q. So it's a singular letter that he's using, and that is the parameter for that. Now the malicious C2 binary connects to a specific URL to get the commands to actually be executed. And if you pay attention to this, every single one of these base 64 encoded commands are being sent to the same exact path, the same exact URI. So it's the 9AB62B5. And that is the answer for this question, 9AB62B5. What is the HTTP method? We already talked about that as well. It is the get method that is being used to retrieve all of these commands. And based on the user agent, what programming language was used by the attacker? So we need to scroll a little bit to the right here so that we can actually go to the user agent portion. And so when you get to the user agent column, oh, I went way too far. When you get to the user agent column, you see that there's the HTTP client, and then NIM is the HTTP client, and that was the answer in this particular question as well. So real quick, we were able, and this one actually I was able to, when I was recording it live, I was also able to retrieve all of these questions fairly quickly, because Brim does a really good job of kind of compartmentalizing data so you can analyze it quickly. You could have done all of those things on Wireshark as well. Brim just does a pretty decent job of splitting everything into different columns so that you can access the information relatively quickly without running too many queries. So that was the access of the malicious document. Now that he's established all of his access that he needs, now he needs to do some reconnaissance, right? So the internal recon is what he's going to be doing. And so far, we've discovered that there was a malicious binary that continually uses command and control C2 traffic, and we can easily decode it using base64 decoder. And the traffic contains the command and the output that was executed by the attacker. So in this portion, the guide that they give us is to find network and process events connecting to the malicious domain, find network events that contain an encoded command, and then we're going to use Brim to filter all the packets and look for endpoint enumeration commands, since the attacker is already inside of the machine. So now we have this updated query for Brim that we're going to end up modifying to be able to get a little bit more information here. So I'm going to just pull this up on my second monitor so I can type it up real quick, and we're just going to be using the same domain, because this is the official domain that's been used for all of the C2 communications. So we do need the ID response port, which is going to be I'll just start with 8080, or I think 80 was the very first one, and then he establishes a full connection and he runs the rest of his commands on 8080. And then we're going to cut the timestamp, we're going to cut the host, we're going to cut the ID response port, and then we're going to cut the URI, and then we are going to sort it by the timestamp. So we want to see essentially everything in order from when it started happening to later on as the day progressed, right? So this is everything that we have on port 80, and then you can see that there is, for every single URI, there is the base 64 encoded requests that are being made on every single one. So the first question here is, they were able to discover a sensitive file inside the machine. What is the password discovered on the affirmation file? So this was actually something that took me a little while to find, because I literally had to go through every single one of them, but it's essentially a PS1 document that he goes through. A PS1 document is a PowerShell script, and inside of the PowerShell script, whoever had written that script had a there we go, PowerShell, and he's running the, oh no, I'm sorry, he's just using PowerShell in this instance. But inside of the script that he found, somebody had hard-coded the password of the user, and that's how he was able to establish that. So this is the netstat query, because the encoded text was just so long. So I'm just going to go back through these again just so I can find, boom, there we go. So this is the actual PowerShell script, right? So he's concatenating the contents of the PowerShell script to see what's inside of it. And then we can see that there's a user variable, which is Benimaru. And then there's the password for that user, which is the Inferno Tempest. And it's been hard-coded into it. And then, of course, it converts it into a secure string and all of that. But the password has now been encoded or hard-coded into the script, which is it's a big no-no, right? Like when you're doing this, it's much better to give an input command to prompt the user to enter their password, so you don't hard code anything into the script. And this is the reason why, because somebody can go through all of your files and then they'll be like, oh, I found so-and-so's password. So they were able to discover the sensitive file that actually has that password. And then they enumerated the list of listening ports inside the machine. What is the listening port that they used? And I want to say I think it was this one that they used, and we had the response. Nope, that's not it, because it's too short. So it's definitely this one. We see the netstat report that he was able to. Yeah, this is definitely it. And inside of this netstat report, or this command, I guess, that he ran, he found all of the TCP connections, or the TCP port connections that were listening. So these are all of the listening ports for netstat. Now, the way that I was able to find the answer is I literally copied this whole thing, and then I went to Gemini and I was like, hey, out of this entire list of stuff, what do you think is a good resource or a good target for somebody to be able to use for remote connection? And so Gemini analyzed that whole thing, and it's like, okay, well, there are potentially suspicious ports, which is 5040, 7680, etc. And then there's the less suspicious, but they're still worth investigating. And they're less suspicious because these are legitimate ports. And this is actually, if it's a good hacker, they would use legitimate ports to establish their connection. So, RPC endpoint mapper, it can be exploited. It's generally not a primary choice for C2. SMB, server message block, it's used for file sharing, right? And then we have 5357, which is for web services for devices. And then you have PowerShell remoting. And this person, whoever this person was, pretty much was running PowerShell commands for the rest of their attack and for the rest of their communication with our local machine. So 5985 was just it stood out immediately, and that was indeed the answer that we were able to find. So the listening port that would provide a remote shell inside that machine was that PowerShell remote port. And it actually says it inside of Gemini where, it goes, listen, it can be used by attackers. It's also a legitimate tool. If you don't need PowerShell remoting, you should disable this because somebody can connect to it and they could hack you, which is exactly what happened here. The next question is, the attacker then establishes a reverse SOC proxy to access the internal services hosted inside of the machine. What is the command that was used by the attacker to establish that connection? So for that answer, we go back into our timeline explorer. And for the reverse SOC proxy, so we're going to be going through a series of commands really here, but there is just a way that you can even just kind of filter through this. If you are looking for something that is a SOC proxy, you literally can just type in SOCs, right? And you would be able to find the singular command that was used to establish a reverse SOC proxy. There are a lot of different ways that you can filter through this. You can go through this specific portion where we can look at the payload that was used, which was the first.exe, which was one of the exploits or the payloads that he had downloaded and he ran it. There was also the process creation mechanism that can be used because he was using a process creation event to be able to run that. But the most obvious way to be able to find something like that, especially when you have inside of the information or inside of the question, you've been given a very obvious hint where it's like, okay, they created a SOC proxy. So we need to go ahead and find what that reverse SOC proxy was. And so that's the way that we were able to find it. And I'm going to kind of minimize this a little bit to make it a little bit easier for us to navigate through this. But it's under the executable. Most of the information that we're going to find from here on that has to do with the timeline explorer is going to be inside of the commands that were executed. So this is the command that was executed. We have the ch.exe, which was the executable that he actually ran, and then he connected to the client, which is the IP address of his malicious domain, right? So 171 or 167.71.199.191. This is the one that we found earlier in the exercise, and he did it on port 8080. So essentially every communication after this connection is done on port 8080, and it's of course a reverse SOC connection, and literally all you do is just search for SOCs and you would be able to find it. So the full path for that, they're saying to remove the double quotes from the log. So you can see right here where it has the quote here and then the quote right there. So if you double click on that, it opens up this whole thing. You can highlight this and copy it, and then and I think you might even be able to, can we modify it in here? We can't modify it in here. So basically what I've been doing, I've just go to my CyberChef because I can paste it in here, and then I just go boom, and then go right there and boom, and then I copy that, and then I bring that as my response for the question. So what is the SHA-256 hash of the binary that was used to establish that reverse SOC proxy? And that's very, very easy. So on the same exact line, we just scroll a little bit to the left here, and under payload data 3 is where all of the hashes are stored. So we open this thing up, and then you just highlight the value of SHA-256, which is that, and then you copy that, and then you come over here and you paste that, and that would be SHA-256. Now, what is the name of the tool that was used based on that hash? So we'll take the same exact hash and we go to our virus total database, which is a very useful tool. And I did not copy the hash, so let me go ahead and copy the hash real quick. But basically, you literally take any hash value. If you just want to see what it is, you can drop a file in here. You can look at IP addresses. You can look at domain names. So if you drop the hash value of the file, it'll say at the very top that this hash value belongs to this file. And that file could be renamed, which was done in multiple instances. So in this case, it was renamed to first.exe, right? But in the original name is chisel, and you don't need the .exe at the end of it. You could just do chisel, and that would be the answer. And then they used the harvested credentials from the machine based on the succeeding process after the execution of the SOC's proxy. What service did the attacker use to authenticate? So the way that we can find this is we're just going to highlight this line, and we're going to remove the SOC's portion of this, okay? And one of the things that we need to do is we need to organize this by the timestamp. So I'm going to do timestamp created or time created, and then I'm going to go back to my executable portion so I can see the SOC's proxy element of this, right? So what we're looking for is the command that was ran after the fact, right? And there seems to be something else that I may have entered as no. So there is no other element that was entered here, but we do need to narrow it down by our, and I mean, it literally is the next command that does show up anyway, but it would be much more useful if we narrowed it down by the Benimaru user, because we're looking at all of the other users right now. So we'll go to username, we'll click on this filter up here, and then we're going to do Benimaru, and he's actually right there. And there we go, Tempest or source user Tempest, and then I'll just do Tempest Benimaru as well. So all of his commands show up. So there's that. And so now we can go over here and we can look at all of the executables and then just find what was next in line after that SOC's proxy. So I'll do the search for SOCs one more time so we could just narrow it down to that one command. We'll highlight this command and then we'll remove SOCs. And now it's going to be highlighted on our timeline. And the very next command in line, so the succeeding command, that's what they're asking, right? So they're saying the attacker then used the credentials from the machine, and based on the succeeding process after the execution, what service did they use? So this is the succeeding process. This is the very next thing that was done. Now, this is also a legitimate process here. So WSM prov host, that's actually also a legitimate Windows process. So if we go and search to see what is connected to that process, which is, of course, the very next thing that I did. So I went and asked what legitimate Windows process is associated with this executable. And the very first response that came up was Windows Remote Management, also known as WinRM. So Windows Remote Management was used to essentially run the rest of the commands in his exercises or in what he was doing. So WinRM would be the answer for this question. And that, just like that, we have all of the answers for task 7. And now we can move on to the next piece, which is now he's actually doing some privilege escalation. So far, we know that they now have a reverse SOC's proxy and they used WinRM or that WSM, whatever executable. So now we're looking for events that are executed after that execution of the reverse SOC's proxy, and for potential privilege escalation attempts, as the attacker has already established a persistent low privileged access. So we're going to look at the packet capture file, and then we're going to look at sysmon again. So first and foremost, we are discovering the privileges of after discovering the privileges of the current user, the attacker then downloaded another binary to be used for privilege escalation. What is the name and the hash value of that binary? So we're going to go to the timeline explorer, and there needs to, I know I have more than enough time, so I'll just add another hour just for the hell of it. So we're going to go back here, and now we know that the parent process of this is going to be the WSM prov host, etc. So what we want to do is I'm going to go ahead and it would be under parent process. Where is that information? We just need to narrow it down for that parent process. I think it's in this column. No, right here in this column. Parent process would be in payload data 4. So I'm going to go click on that, and we're going to filter it to the WSM, whatever that thing is. And it's literally one item that will show up. So there we go. So this is all the stuff that was done with the after the WinRM established connection was done. So then we go back into our executable info, and we can see a few things, right? So first he wants to see what his privileges are as the user that he's logged in. And then he goes and downloads spf.exe from the fish team, and then final.exe from the fish team. And then he runs both of those together, right? So he'll run the spf exe and the final exe. And this is the command that officially will have the hash value for the spf.exe, because these commands are technically going to use the hash value for PowerShell to be able to run for us. So we're going to find the hash value of spf.exe. So then we just highlight that, and then we go to the left, and then we go under the hashes here, open that up, and then we go over here and highlight the SHA-256, and then copy the hash value of that. And then so you go here and you would do spf.exe as the name, comma, the hash value, which is exactly what we found over here. So that's the first question. Then it says, based on the hash value of the binary, what's the name of the tool that was used? So again, we'll go back to VirusTotal, and we'll go here and we'll paste that hash value, and then we'll look for it. And it says print spoofer. printspoofer64.exe is the name of the tool. And so you just need print spoofer, and that's the answer for it. And then it says the tool exploits a specific privilege that's owned by the user. What's the name of the privilege? So to find this, I literally just Googled it, and it was, let's see what we can do. I've completely forgot what the question was, but it was basically print spoofer. Let's do that, and then we'll do print spoofer 64 privilege vulnerability. Let's say that. We'll do that. And based on this, we'll be able to get some information. And specifically, what you're more interested in is the actual print spoofer GitHub page. And from there, right at the very top right here, you'll see that the SE impersonate privilege is what was abused on the computer. And that is the answer. The SE impersonate privilege is what the specific privilege that was exploited, right? It's the impersonation that print spoofer is taking advantage of. Then the attacker executed the tool with another binary to establish that connection, and we already have that over here. It's right next to the command itself, or it's inside of the command itself, which is the final.exe. So he executed this along with that other binary, and that was the final.exe. And the binary connects to a different port from the first C2 connection, and that was port 8080. And we can find that inside of our brim. There we go. So inside of the brim, if I just remove this portion and I only look at the stuff that was done with that C2 server, we can see that there's only two ports that are available. We have port 80, and then we have port 8080 that was done. And essentially all of the commands are run in either of these ports, and then everything that was done on port 80 was before he had that final connection, and then port 8080 is after he had that final connection. You can also just go to the timeline explorer, and then over here we can delete our last filter down here for the payload data to remove that MSMProv host portion, and then we can filter based on 8080 just as the information to see what shows up. And it's again inside of this command where he's using to establish his reverse SOCs connection. So 8080 on his IP address, that's the port number that he's used to establish that connection. If you don't know, if you didn't know what the port was, right? If you didn't know what the connection for that was, there's a few different ways that you could look for it, right? Because you know that he's establishing a SOCs connection. So we could technically just go and look for the SOCs keyword again. Or if you know that the IP address, the original IP address, that was his malicious IP address, was the one that he was going to use to establish that reverse connection, we would just go to our initial portion. which was the malicious document. So was it in this location? Yeah. So this is the malicious IP address that was used for that. So we could just highlight this and then go ahead and search for it inside of our file over here. And it would probably show up more than one result, but there is essentially only one result that actually has this command that was executed that's run on port 8080. So there's a few different ways that you can try to find what the port number was that he established that connection. We can go ahead and look at the parent process that was run, which is the process that was used, which in combination with a few different processes that he had originally. So first.exe was that initial established connection. So we do have that somewhere in our responses as well. All of the responses that you've collected so far are hints for you to be able to use when you do the rest of your search. And that's what you should be doing. You should be combining all of the information that you've gathered to be able to be like, oh, okay, you know what, this is what we've used to establish all of our connections. So port 8080 was the port that was established. But the way that I found it originally is I was just looking at Brim, and I just removed that the ID response port filter that was available over here. And I just looked at all the ports that were connected, and there was only 2 ports that were connected via this domain, and it was port 80 and then 8080. So that was it. There's a few different ways that you can find this specific answer. And now finally, we are moving on to what this person did after they had their reverse connection. They had their reverse SOC connection, and they increased their privileges. So now what do they want to do? The attacker now has gained administrative privileges inside the machine. So we need to find all the persistence techniques that they used after they became admin. Now, one of the things that the first time that I was running through all of these commands right here, one of the things that I did, because I had to go through every single one, was find one of the base 64 encoded commands that this person ran, and they were able to log in as an administrator. And what happened is that it was like towards the later portions of these commands where they run the command to log in as an administrator, and they were successful to log in as an administrator. And then they started creating accounts. So, you know, Cheyenne and Shuna were the 2 accounts that this person created after they were logged in as an admin. So if you actually go through every single one of these values, which is time consuming, I understand, but if you go through every single one of them, you get to see that he's running a variety of different commands. And so he's adding Cheyenne and Shuna. And so let's go back a few to see where he was logging in as the admin. But essentially, they have established administrator access by going through the variety of different attempts at login. And then you can see that by going through the timeline explorer, where there's so many attempts to log in to the machine. So who are my privileges for the person, and he's trying to see what the privileges are that he has access to, and etc., etc. So he will go through, or they will go, whoever this person is, they will go through a variety of different attempts to log in as an admin, and then ultimately they'll start using their admin privileges to actually start adding those new users, because if he's created his own users, then he can establish maintenance or persistence, to be able to add these things. So now here's the thing, right? So this is the first few attempts that this person made to try to add the user, but it was not successful because he's missing, or they are missing, I don't know why I feel like I need to say that, but they're missing a very key element of this adding of the users that they haven't added to any of their commands. So it's very interesting that this person is so strong at attempting these hacks and then actually getting, there we go. So the command completed successfully. This is when they actually were able to log in as the administrator, and they were able to get in. They've been able to do all of these things, but they're missing a key element of adding a user. So they get their persistence, they get their escalated privileges, and now they want to make sure that they stay in the system. So we're going to use Brim to filter everything. And again, we're just going to sort through everything like that. So the port in this particular case is going to be port 8080 because they've already established their connection, and the attacker gained a system. So now the context for each malicious execution blends with the authority system. And then the child events of everything that's being done, we are also going to check out to see what happens. So we're going to look at the package capture, sysmon, and of course the Windows event logs as well, because now there's Windows events that are taking place. And for this, instead of going through the Windows event logs, I just Googled the events because it's very easy to find event IDs if you know what you're looking for. So first and foremost, what were the system access that the attacker then created two users with? And this was a little bit towards the bottom right here. I think I can actually even do this. I can do Control Z a few times to go and see the list of the users that they made. And we would be able to see right here. So all of the users were Cheyenne and Shuna. These were the two users that were created. Now, in order to be able to find that, you would literally just go through every single one of these things. And let me kind of just actually do the response port that will equal to 8080 to filter this down just to these events that we have over here. So it's a little bit, it's like almost immediately right after they get their admin login, and from there is when they start creating the accounts. So accounts still right here, you see that they're Cheyenne and Shu or Schumer or whatever their name is. Those names are no longer present here. So what do we have? The BMV0. So let me see, BMV0. This is the longer one. So I'm just going to go through all of these things just to kind of give you the various events that were used to create the new users, because if I show you the last list, so you can see, right, they're trying to create the Shuna user, but they haven't ran the proper command to do it. So they still haven't created the user, but they're trying to create the user. Net user Shuna princess, still nothing. So they're trying to do it. It's just that they're missing a key element. And of course, we're going to be asked about what that key element is to be able to do it. So it tries to do it and looks, and they're like, oh, the user still wasn't created. So every attempt that I've done so far has been unsuccessful to be able to add the user that I want to add. And ultimately they get it right. So now new user Cheyenne MasterChef, and again, they'll probably run to check to see if the user was added. And of course the user won't be added because they were not successful. So if you add a user, you will actually get a notification that you were successful, and it is missing one key element for them to be able to do it. So I'm going to go through these things, and there we go. So net user administrator change password, they were able to actually log in as an admin, and from there they're going to keep attempting to add those users, and I'm going to find the one where they're finally successful because they ran the proper command. This one is still unsuccessful, so I'll find the one that they actually did to successfully add the user. And we know that they want to add Cheyenne and Schumer, or I keep forgetting the second name, but they want to add these users to the list and then modify them for future access so that they can maintain persistence. All right, there we go. So Shuna, not Schumer. So they were missing the /add portion of this command. And finally, they got a command was completed successfully. So they were able to add Shuna, and ultimately they were able to add Cheyenne. And at the very end, we got to see already where they were looking at the list of the users that they wanted, and they were able to find those two users that they added finally, which is right here. We have the net users, and we have Cheyenne and Shuna that were finally added. So this is where we got these answers. You just had to do a little bit of searching, and obviously you're getting the answers if you're watching this, but I do recommend you actually go through that exercise to try to decode some of those base 64 commands, just so you can get it in the cells of your body of what it's like to go through that process. And it is a little bit time consuming, but that is what it is right now. We are not going to talk about using shell scripting or PowerShell scripting to do something like this, but you can actually create a PowerShell script that will sift and sort through those events inside of the PCAP file and look for any given pattern and then replace or remove the element, right? So what it would do is it would essentially extract the base 64 portion of this, by looking for this and then removing this, and then everything after this until this portion is going to be the base 64 encoded, and then you can use PowerShell to decode that portion. So you can create a script to actually do that for you. It's just beyond the scope of this video, and I don't want to go down the rabbit hole. So these were the users that were used, and now it says the attacker executed commands that failed was the missing option, and that was the /add option. Based on the event logs, the accounts were successfully created. What is the event ID that indicates the account creation? And this is where I went to Google and I just pasted that here. And then the only thing that I did was I changed that to what is the Windows event ID. And then there's only one answer, which is 4720. And that is indeed the response. The attacker added one of the accounts in the local administrator group. What is the command that was used by the attacker to add the user? And so it was the netlocal admin Cheyenne. And so it's, again, just one of these things. So if you go through the remaining list, because it was after them verifying that they added their users, and it was so add Cheyenne Master Chef, they were able to add that user, and that's great. And so now we want to make sure that we add that user to the admin group. And so they just follow along with that. So new accounts, there we go. It's been confirmed. And it's like literally towards the end, because they want to make sure that they have their user inside of the admin. There we go. Net local group administrators add Cheyenne. So you just take this portion, and that's the answer that they're looking for. And that is the answer that we gave them. Based on the Windows event logs, the account was successfully added. What is the event ID that indicates the addition to a sensitive local group? So we take that and we paste that into Google, and then we just put Windows at the beginning. What is the Windows event ID that indicates that? And 4732 is the only response for security enabled group. And that is indeed the answer. So after the account creation, the attacker executed a technique to establish persistent administrative access. What is the command that was used by the attacker to achieve this, right? So this is where it gets a little bit interesting. And this one took me a little bit of time to find. So we're trying to see what they did after establishing that administrative access, or excuse me, after creating that account, they executed a technique to establish that access. So I'm going to walk you through essentially what I did to be able to find that final answer. And I'll do it obviously a little bit more quickly than what I did previously. But this is something that is actually, if you know what you're looking for, if you know what different elements you're looking for, it's kind of easy to find. So let me show you. The first thing that we need to remember is that once they've established their administrator privileges, they're no longer Benimaru, right? So everything that they're doing is now going to be under the NT authority system user. So when we go back into our Timeline Explorer and we're looking at the sysmon CSV file, so we're not inside the Windows. The Windows one, I think, was more for the getting those event IDs and everything. So we're going to go into the user, and we're going to filter for the authority system. And this is the one that we're most interested in. So we're going to only look at the NT authority system user. And then we're going to, of course, go look for the executables that were run to be able to find to be able to create this like persistence portion of it. It is a fairly good amount of information that's available over here. So I'm going to filter the executables just to show us all of the actual commands that actually have values. So we need to click it one more time to bring all the ones that have value. There we go. So let me just kind of scroll to the top here. So these are all the ones that actually have value. So the ones that we are most interested in would be the things that are using the Windows System 32 element. So we can see, if we go over here, we see that Windows 32 service SVC host, and then there's a variety of different commands that are used, net1 users, and then user Shuna Princess and Cheyenne and administrator, all of that, right? Add user, local administrator, etc., 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 etc. So you just keep going, and then you can see if there's anything else that might be relevant to what's going on. So the Tempest is the name of the machine. Tempest is the name of the host, right? And SC is something that is for service creation. So you create a service, and then you're creating Tempest to update. Binary path is going to be the final.exe, which is that final executable, right? That final binary that they wanted to run. And it's going to start on auto, meaning that every time that they boot this computer, it's going to run this thing. So this is actually a scheduled task that's happening. So they are doing sc.exe. The user itself is Tempest, and they're creating this specific service called the Tempest Update 2, and the service that will, the binary that will launch for this service is going to be this final exe. So there are a few different ways that we can find this. I just narrowed it down by Tempest because I just wanted to see where it was. But technically, you could even do final.exe, and it would pull up everything that has to do with that binary, that final binary. And it's a smaller list. It's a much smaller list because, again, we already established, right? So if we go through our information, all of the data that we gathered previously, they executed a tool with another binary to establish their C2 connection. What is the name of the binary that they executed? It's that final exe. And when you do this in a real environment, in the real world, you need to make note of all of the artifacts that you found and all the data that you gathered. And final.exe would be the last piece in the timeline of activity that this person did. That would be one of the final pieces. And they used this to establish their connection on port 8080, etc. So that would be the big thing that you would search for, is that final.exe binary. And so when we do that, and then we organize our executables to actually only show us the stuff that have value inside of them, then it's fairly easy to kind of narrow this down. So we have, the original final exe, looking at your privileges, etc. And then you have these creation of these services, and create is another one of those kind of red flag types of events where it's like, oh, what are you creating here? And so they're creating this automated service, this service that will launch every single time the computer boots, and then it's going to be that binary, that final.exe. So this is the full command, because the second one is the one that I think was the most successful, because if they do one Tempest update and then they do two, that means the second one would be the one that would be of note or of interest. And so remove the double quotes as the other one as well. So again, just open this and then highlight this whole thing and text it inside of it, take it inside of a text editor, remove that quote, and then remove that quote, and then take the whole thing again and then paste it in here, and that would be your answer. And that was the final answer that you needed to complete this exercise. And let me tell you, I went through a good, let's say, hour and a half of recording, 2 hours of recording, and then the freaking OBS acted up, and all of a sudden I lost the recording, and I'm sitting here in front of the computer. I'm like, oh my God, I can't believe that just happened to me. But we made it. We actually made it to the end of this, so I'm very excited that I hope you persisted. I hope you went through this whole thing with me. It's a very, very cool exercise. I loved it because it did test me in some places, and I got a chance to run some command line tools that I haven't ran before, and we were able to deal with certain files that I had not dealt with before. So it was cool. It was like a nice experience to be able to actually run through this thing, and I got a chance to learn, and I hope you got a chance to learn as well. And I hope if you already knew some of these things, that this became kind of another exercise that embedded or further embedded this process into your system. And Brim is an amazing tool. I love Brim. Of course, the Timeline Explorer was very useful. It was nice to be able to learn how to create various filters inside of Timeline Explorer. We went through an entire investigation. If you really think about it, we actually did of course, looking at the various artifacts, or modifying our artifacts, formatting. That's the word I'm looking for. Formatting the artifacts that we were using so that we can go ahead and prepare them for the investigation. And then we first looked at the things that were downloaded and what they did to establish that initial foothold and get their foot in the door, so to speak. And then they were able to use that foothold that they had to download several other binaries so that they can get themselves persistent access. And then they escalated their privileges and became administrator. And then they created new users. and added those users to an admin, or at least one of those users was added to an admin group, and assuming that would have never been discovered, this person would have been able to log in as that new user and be able to do everything that they wanted to do without having to log in as the administrator user specifically, because that's a red flag. Like when you log in as the administrator user, the system security will kind of fire all the alarms and it'll be like, hey, somebody's logging as admin. So if you log in as a normal user, just, Schumer or whatever, Cheyenne, if you log in as the normal user, but you have admin privileges, it's not that big of a deal, right? So specifically, if you log in as the admin, there's a lot of configurations that have been established that, oh, somebody's logging in as admin, and then it raises flags. So in this particular case, they were not successful because we caught them and we were able to investigate what happened. And that was the whole purpose of this exercise. And it was really cool. I liked it. I hope you liked it too. And I hope you learned a lot from it. To get more videos like this one as we go through the rest of the SOC Level 1 capture the flag exercises and the investigations and everything that we're doing, make sure that you like, subscribe, and turn on the notification bell. And of course, drop a comment. This was actually quite a complicated room. So if you have any questions or if you need any clarity on anything, please let me know. I tried my best to explain it in the best detail that I possibly could. So hopefully it wasn't too much of an explanation, but hopefully it was enough to be able to get you to go through it and understand what just happened. And then we have obviously the future videos that are going to come out on SOC Level 2, and then we have the pen tester stuff that we're going to do and everything else that we're going to do for web hacking and AI cybersecurity, all that. So there's a lot of content that's going to be coming up, and these things become more and more complex. So this took me 2 days to record the video for this one room because it was very time consuming to be able to go through that initial investigation. And then what you see is just all of the cut up pieces, but it was a good total of like 5-6 hours that was dedicated just to recording this one video for you. And it's going to be less frequent, I think. The uploads will not be as many, but they're going to be really jam-packed with a lot of value because we're doing more advanced stuff from this moment forward. We did all the CySec 101 playlist, so now everything that we're going to do from now on is going to be more advanced stuff. SOC Level 1, SOC Level 2, pen tester, ethical hacker, AI cybersecurity, all of those things. So it's just going to become bigger pieces of content because all of the foundation has been set. We've talked about all the fundamentals, and now it's time to talk about all the really crazy fun stuff. So I hope that you like, subscribe, turn on the notification bell, and of course drop a comment so that you get notified the next time that these videos come out. If you're serious about your SysAdmin training and want to get access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the supporter, agent, guardian, and master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. I hope I see you in the Discord chats. If not, I hope I see you in the comment section, and that is it. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker/protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease, and I will see you in the next video later.